Welcome to our second concept video in Chapter 7a. This time we're going to be looking at power property and the zero exponent property. We're going to put them together. It should be very, very quick and easy. Now we know that when we hear powers means exponents. So when you are looking at these examples, what you're going to notice is that you're going to have an exponent outside of a parentheses. Okay, so what that means, whenever we see parentheses is a way for grouping. So when we see an exponent outside of the parentheses, what we need to do with that exponent is distribute it inside to the parentheses, to every part, okay? And we know what the parts are. We were looking at them in 7.1. Remember, we have the coefficient, and then we have the base with the exponent. Okay, so every part is going to receive the exponent that's on the outside of the parentheses, but in a little bit of a different way, and I'll tell you what I mean by that. So first, let's fill in our blanks here. To simplify an expression using the power property, we need to distribute that exponent inside. Okay, the coefficients, so that means, look at this example here, our coefficient, let me rewrite this, 3a to the fourth squared. Our coefficient is 3. So our coefficients are going to treat the exponent as a normal exponent, as a power. So if I were going to, let me get a red pen here. If I was going to distribute this 2 inside here to the 3, it would go to the coefficient just like a regular power. So in this example, it would just be normal 3 squared. And we know 3 squared, 3 times 3, that's going to give us 9. Then you also need to distribute it inside to the base and the exponent, just like we have been before. I was boxing my coefficients and highlighting my base and exponents. So this power needs to be distributed here as well. Now, bases are going to treat the exponent as multiplication. So remember in 7.1 we had to add our exponents and it was a little bit weird. Now this time you're going to be multiplying your exponents. So when I distribute this squared, or this power of 2 inside the parentheses, you're going to have this exponent 4 times this exponent of 2. So that's going to be a to the 4 times 2 is 8. So 9a to the 8th power. All right. Now, if that's a little bit confusing, you can write it a little bit of a different way. Now, 3a to the 4th power squared just means that whatever's inside the parentheses you're multiplying by itself. So another way we could have done this is 3a to the 4th power times 3a to the 4th power. Now, this should look just like what we were doing in 7.1, where we would have 2 coefficients, base and exponent, and then we would do our math. 3 times 3 would give us 9. Keep the bases the same, add the exponents. 4 and 4 would be 8. Do you see how these two are going to yield the same answer? This way of doing it and this way of doing it are the same thing. You can just pick whichever one works best for you. Okay, so let's look at some more examples here. Let's start with number 13. And remember, I told you always you want to rewrite the problem so that you have a coefficient, a base, and an exponent. So just like in number 13, we don't see a coefficient, but it's going to be really helpful if we go ahead and rewrite it in there for us. All right, so I'm just going to label my parts the same way I did in 7.1. I'm going to box my coefficients, and I'm going to highlight my base and exponent. All right, so I need to distribute this 4 to this part and to this part. So 1 to the 4th power is going to be like 1 times 1 times 1 times 1. Always going to be 1. And then x squared to the 4th power, remember we are going to multiply our exponents, so that means x to the 8th power. Okay, let's go look at 14. We have 2r to the 5th power to another 5th power. All right, so we need to box our coefficient and highlight our base and exponent. And let's distribute in this power. 2 to the 5th power is 2 times 2 times 2 times 2 times 2. 32. R to the 5th power, remember we're multiplying the exponents, so that becomes r to the 25th power. Let's keep going. Number 15, we have 3x to the 1st power. Remember, if there's no exponent, it's 1 to the 3rd power. So let's box our coefficients, highlight our base and exponent, and do the rest of this math. 3 to the third power is going to give us 27, and 1 times 3. Okay, number 16, 3k squared to the fourth power. Box our coefficients, highlight our base and exponent. Let's distribute. 3 to the fourth power is 81. K, we have k squared to the fourth power, multiply your exponents is k to the eighth. Okay. 17, 3x to the fourth power to the fourth power. Let's box our coefficients, highlight base and exponent, and distribute. Once again, we have 3 to the fourth power, just like in the problem before this. So we already know that that's 81. And then we have x to the fourth raised to another fourth power, multiply the exponents. So that's going to be 16. All right, 18. Now we're going to get into a little bit more difficult, but not too bad. We have two variables. We have x squared, and we've got, y cubed. And I forgot to box my coefficients. Let me do that. All right, so we have to distribute this power of 3 that's on the outside of our parentheses. We still have to do that, but this time we're doing it to 3 different parts instead of 2. So 2 cubed is going to give us 8, and then we have to distribute the cubed to this part and to this part. So you're just going to be multiplying exponents twice. We have x, we have 2 times 3, so x to the 6th, and 3 times 3, y to the 9th. Not too different, right? Number 19. Remember, in number 19, y does not have an exponent, but let's write it. 3y to the first power, x to the fourth, and the whole thing is being cubed. So we need to box our coefficient, highlight our variable, and then distribute. 3 to the third power is 27. Y, 1 times 3 is third power. X, 4 times 3 is 12. Okay, let's do one more. 20. 3n, and what to the first power? Remember, write those exponents and those coefficients if they are not there, because otherwise you might end up confusing yourself. Okay, so here I am highlighting, boxing. 3 squared is 3 times 3, that's 9. M we have to the first power times 2. 1 times 2 is 2. M squared is going to be 4. 2 times 2 is 4. Okay? All right, let's flip over. So 21 and 23 get a little messier. I'm going to do those two also. 22 and 24 are yours. So in 21, 2x to the fourth power, y squared, the whole thing to the fourth. I want you to pause and try this one on your own. And 23, let's do that one also. 3p cubed, cubed, that's hard to say, r squared, and the whole thing squared. All right, so let's box that coefficient, highlight our variables, p, q, and I have a third one. I've got r, so I need my pink highlighter. And distribute. 3 squared is going to be 9. We have p to the third times 2, that's p to the 6th. Q, same thing, 3 times 2, again 6. And R, 2 times 2 is to the 4th. Okay. All right, one last part of this that we need to look at, and that's called the zero exponent property. Now, listen very carefully to what I'm going to say. It's very, very easy. Any number, any, or variable that it's raised to the power of 0 is 1. Always, always, always. So if I tell you 10 to the first power, it's 1. If I tell you 500 x to the first power, that's 1. If I tell you 2,386,534 to the first power, or I'm sorry, to the 0 power, what is wrong with me? That's 1. Okay, so anything to the 0 power, I'm so sorry if I just confused you. Anything to the 0 power is 1. Okay, all right, so number 25, let's look at this. Notice we have some variables to the 0 power. Now, when you have a variable to a 0 power, here's what happens. M to the 0 power is gone. It's just 1. Okay, so what you could do is I would take a marker or a pencil or something and scratch it out. Anything to the 0 power. However, look at this part. 2nm to the 0 power. That does not mean that this whole thing is to the 0 power. Only m is to the 0 power, not 2 and n. Okay, so we cross that one out. All right, so now we're going to kind of put together our product property and our exponent property and do the math that we need to do here. So n squared is, remember, no coefficient, we write in 1n squared times 2n to the first power, because we have no exponent, cubed. Now, the reason that I don't have to do anything when I cross out the m to the 0 power, m to the 0 power, is because they become 1. And at that point, anything times 1 is just itself. 5 times 1 is still 5. 1,000,000 times 1 is still 1,000,000, okay? So it's just kind of like canceling it out, to be honest. All right, so let's do the math here on the inside of our parentheses, and then we'll cube everything. We'll deal with the exponent that's here on the outside. We'll do that last. So we have 1 and 2, which are our coefficients, n squared and n squared. This is our base and our exponent. Let's do that math inside our parentheses. 1 times 2 is 2, n, add the exponents, 2 and 1 is 3. And then that whole thing is still being cubed. Don't forget about that cubed. So now we have to use our power property as well, where we have to distribute that exponent here and here. So 2 cubed is 8, and then we have 3 times 3. Remember, when you have a power on a power, you end up multiplying those exponents. So that'll be 9. Let's go to 27. Okay, I'm just going to go down and do the odds here with you. We have x to the 0 power. Oh, look, to the 0 power. It's gone. And then we still have y to the 4th inside the parentheses, but look here what's outside of the parentheses. So that's like saying y to the 4th to the 0 power. So again, this whole thing is gone now. Okay? Now all we have to deal with is what's over here. And if this is being multiplied by 1, anything times 1 is just itself. So you probably were thinking that this one was going to be hard. That's your answer. There's nothing left to do. All right, and 29. Now, once again, be careful with these. A lot of people are going to look at this first term here, and you're going to go 2y to the 0 power is 1. Well, only this part of it is 1, y to the 0 power. Okay, if this were inside parentheses like this, here off to the side real quick, if it were like this, then yes, 2 and y would both be gone, the whole thing. But it's not. This exponent, as it is right now, only applies to the variable. So the 2 is still there. 2 times 1 is 2, but the variable is gone. Okay, same thing with this x to the 0. That one's gone as well. Okay, so all we have left here is 2 times y has no coefficient, so let's write it in 1y, and it also has no variable to the first power. Remember, if it's not there, it's 1. And then x to the 4th. We just need to do our multiplication. So we have coefficients 2 and 1, and then we have our variables. We've got y to the 1st, and we've got x to the 4th. Okay, so let's do our math, our multiplication. 2 times 1 is 2, and then we only have y to the 1st and x to the 4th. There's nothing to multiply that by, so just rewrite it. Kind of like it comes along for the ride, and that's your answer. Okay, so I want you to try these last even problems. We've got 22, 24, 26, 28, and 30. So do these last 5, try them on your own. Don't forget to do your summary questions. Have a good night, guys.